given dy by dx and we're asked to find the second derivative, so we have to differentiate again. So the second derivative d2y by dx twice, so 54 is going to disappear, the 27x is going to become 27, and bring down the power, take 1 off the power, minus 12x, and that's worth 2 marks on its own. Now part 2, a lot of students managed to get 1 mark out of 4 here. It says verify that the curve has a minimum point at P. So the first thing we have to do is show that it has a stationary point at P before verifying it, and that's why it's worth 4 marks. So the first step is to show that dy by dx equals 0 when x equals minus 1.5, which I'm going to straight away change to minus 3 over 2, because it's just, I know already it's going to make it so much easier than a mixed number. So we've got 54 plus 27 lots of minus 3 over 2 minus 6 lots of minus 3 over 2 squared. So 54 plus, now here actually it's going to be negative, isn't it? Because if I times it by 3, 27 times 3 is 81, so minus 81 halves. So I'm just multiplying by the 27 there, or multiplying by 27 over 1. Minus, and the 6, I'm just going to take a little bit more time over this. If I'm squaring 1.5, it's going to become a positive 9 over 4. Okay, so 54 minus 81 over 2, 6 times 9 is going to be 54. And what I'm hoping to do here is to show that this equals 0. So we just need to take our time through this. If we make it all quarters, so this thing here is going to become 216 quarters. This one here is 162 quarters minus 54 quarters. And 54 plus 162 is 216. So that equals 0, and therefore P is a stationary point. So that was worth 2 marks. And then, so once we've shown that, we then want to show that it's a minimum. So we need to then show the second derivative, d2y by dx twice, is a minimum, so therefore it should be a positive value, so it should be greater than 0 for it to be a minimum. And this is all still part of part 2, so let's just box off what I'm doing here, just so it's really, really clear. So I'm going to put minus 3 over 2 into there, 27 minus 12 lots of minus 3 over 2. So 12 times by 3 divided by 2 is 36 over 2, which is 18. So I do 27 minus 18, which is a positive number. So it's a positive number, 45. Now that is positive, and therefore it's a minimum. So it was important to show all those steps. If you just did this bit in the box here, you only got 1 mark. You had to do all of the work to get that correct. Now moving on to part B, which asks us to show that this inequality is true when the curve is decreasing. So we know that dy by dx is less than 0 when it is decreasing, i.e. it has a negative gradient. The change in y over x is negative. So therefore what we're going to do is we're going to put 54 plus 27x minus 6x squared, make that less than 0. And we're trying to get it into this form. So different ways you can do this, but overall we know we're going to have to divide by 3 to get the 2x. So if we divide each thing by 3, I get 2x squared, I get a positive 9x, and 3's into 54 go 18 times. got 18 there, which I can see is going to happen. So I've missed that should be a minus at the minute, minus in there. And then I'm going to times through by -1. And when you times through by -1, it changes the sign of each thing, obviously, and it also flips the inequality symbol round. The other option you've got is just to move everything over to the other side, but I prefer this way. I feel this is a bit more mathematical. So I've got -18 minus 9x plus 2x squared is now bigger than 0. Just tidy this up by rearranging it into the format that it wanted us to get it, which is there. And then we've got our 2 marks. For part 2, solving the inequality. So here we now have a quadratic and we are looking to factorise this. Now, ideally, we should be factorising. If we can't, we can use the quadratic formula. But we're going to have a 2x and we're going to have an x. And we're looking for numbers which multiply to make 18 and add up to make -9. So the pairs of numbers we've got are 2 and 9, 3 and 6 are probably our options. If we double one of these, we're looking to find a difference between them as 9. So if we double these ones, we're not getting anywhere close. If I double this, I get 12 and 3 with a difference of 9. So I'm doubling the 6, so I'm going to be doing 2x times 6, and I'm going to be leaving the 3 alone. And I want it to be -12 plus 3 to give myself my -9 there. So all of that is greater than 0. So my two values of x are -3/2 or 6. So then if I quickly draw myself out a sketch here, here's -3/2 and here's 6, and it's going to look something like that. Okay, ideally, let's try and get it so my curve actually does go through the points, so 6 there. Now I want this when it's greater than 0, so I want the section when it's above the axis. So this section here and this section here. So x is either smaller than -3/2 or x is greater than 6. And drawing the sign diagram or drawing a sketch here is what guarantees you all 4 marks for that final question.